So a few extra bonus problems for section 3.6. We're going to start by looking at r of x equals x squared minus 9 over x squared. Now there's a couple things I'd probably ask for on something like this. I guess the first thing that we could look for would be the x-intercepts. So x-intercepts, where the graph crosses the x-axis, also sometimes called the roots. So to find that, you're going to set the numerator equal to 0. And I'll demonstrate why we do that later. But for now, if we set the numerator equal to 0, that's going to be x squared minus 9 equals 0. Hopefully you don't do anything really involved to solve this. And hopefully you remember that when you take the square root here, there's a plus or minus square root. So plus or minus 3. So let's keep track of that in a little t-table over here, x and y. Let's see, 3 for x, 0 for y, negative 3 for x, also 0 for y. As far as finding the y-intercepts is concerned, we're going to want to try and find where it crosses the y-axis. And typically, for the y-intercept, you set x equal to 0. But that's going to create a problem here, right? Can anyone see the problem that we're going to have when we set x equal to 0?
Division by 0.
Yeah, dividing by 0. So that can't work. So kind of a bummer. No x-intercepts. So thank you. All right. Now that kind of brings us to another problem or something we can discuss and look at with regard to this function, and that is where the denominator equals 0. And where the denominator equals 0 is where we have our vertical asymptotes. So our vertical asymptotes to find those, you're going to set the denominator equals 0. So denom equals 0. And that's not really that difficult to solve. It's just x squared equals 0 or x equals 0. There's only one vertical asymptote. So, okay. How about the horizontal asymptotes? Because certainly something I'm going to ask you to show me in a graph like this is where the horizontal asymptotes are, if there is one. Now in this case, there is one. So the horizontal asymptote, and I'm just going to abbreviate that, HA. We can actually calculate that very nicely because in this particular example, the degree in the numerator and the degree in the denominator are the same. That means that the horizontal asymptote is just the ratio of the leading coefficients. So a 1 and a 1 here. Okay. So our horizontal asymptote is the ratio of 1 over 1. Basically just y equals 1 is our horizontal asymptote. Nice. Let's see that the graph matches up with all these things, and then I'll finish it by asking you for the domain and the range. So here's our function. Let me kind of zoom around a little bit, and we'll do this. There we go. So there's your graph. And, you know, it goes off towards positive infinity that direction, and out towards positive infinity the other direction. Actually, it doesn't get to positive infinity. We can actually figure it out. We already did figure out it gets to y equals 1. There's your horizontal asymptote. So it gets close to but never touches this line. Let me put it in a different color to make it a little bit clearer that that's not the part of the graph. It's just getting close to that line. All right, let me shut that off. What else? We wanted x and y intercepts. There is no y-intercept, but there are x-intercepts exactly where we thought they'd be at -3 and 0. Between -3, 0, and then 3 and 0. Perfect. The last thing I guess I would ask would be for the domain. Now, as far as the domain is concerned, you can get that by looking at the function itself, because what we want to avoid is we want to avoid where the denominator equals 0. So the domain is everything but that. So if we're going to avoid 0, that means we're going to have everything from negative infinity to 0, parenthesis, 0 to infinity. Always lowest to highest, lowest to highest. So that union that, that's your domain. For the range, you're probably going to want to look at the graph. It's not as clear as what the range would be. The range is which coordinate of your graph on the coordinate plane. It's the y coordinate. And those y coordinates go all the way down towards negative infinity, but all the way up to what point do they stop at? Where do they top out?
1.
They stop out at 1. So your range is going to be negative infinity to 1. Now here's the big question. Is that 1 going to get a bracket or a parenthesis? Does this graph ever touch y equal 1? Parentheses, because it gets close to, but it never quite touches. So the correct answer there would be a parenthesis. Beautiful. Okay, let's try another one, unless there's some more comments or thoughts on this one. I think we nailed that one. So the next one I'm going to look at is going to be this one right here. And let me put that up for you over here. So it's going to be y equals 6x plus 1 over 4x squared plus 1. And I'm going to ask you the same kind of things that I did just a moment ago. And that is, I'm going to start out by asking you what's the vertical and horizontal asymptotes. We'll start out with the vertical asymptote. How do we find the vertical asymptote? What am I going to do to find that one? What do you think? How do we find the vertical asymptote?
Set the denominator to 0.
Thank you. Set the denominator equals 0. 4x squared plus 1 equals 0. 4x squared equals negative 1. X squared equals negative 1/4. X is going to be plus or minus the square root of negative 1/4. Hopefully you realize that that's going to give you an imaginary number because you've got a negative underneath the radical. Precisely, it would be plus or minus 1/2 times I. And that's basically saying that your horizontal asymptotes are only in your imagination. This has no horizontal asymptotes. Horizontal asymptotes have to be real numbers, not complex and or imaginary. So we're good there. How about the horizontal asymptote? Horizontal asymptote. Well, that's a little different in this case. Now, if I was putting a little quiz on one of those Panopto videos that I've done for you a couple times, I'd make this a multiple choice, and one of the choices would be 6/4. Y equals 6/4. Is that the horizontal asymptote here?
No.
No. And the reason for that is because the degree here is a 1 and the degree here is a 2. This is going to grow a lot faster than this one, so eventually this gets down to y equals 0 is where it's going to go. That's going to be its kind of long-term or end behavior, as that will be its horizontal asymptote.
Hello?
Yes. Hello.
Oh, I'm sorry.
Is there a question? All right, so let's see if we can't figure out some other things about this. How about the X and Y intercepts? So X-intercept, set Y equal to 0. And that's going to be, well, let's see. Let's start back here at y equals 6x plus 1 over 4x squared plus 1. If I set y equal to 0, that's going to look like 0 equals 6x plus 1 over 4x squared plus 1. Now, solving this is actually a lot easier than you think. Because what I'm going to do is I'm going to get rid of the denominator. You can get rid of the denominator by multiplying both sides by 4x squared plus 1. Yes?
How come in the other one you set the numerator equal to 0, but this one it's y?
It's a great question. Why did I set the numerator equal 0 in the last one, and I'm setting y equals 0 in this one? Hang on to that, because you'll see. So, I'll tell you what, Henry, maybe you can help me out here. Can you simplify this equation for me? I've multiplied both sides by 4x squared plus 1.
It's 0 equals 6x plus 1.
Perfect. 0 equals 6x plus 1. And so to directly answer your question, the net effect of setting y equal to 0 is really you're going to solve where the numerator equals 0. So I'm just kind of showing you what we did in the first problem is really what you have to do in all of these to find your x-intercept, and that is set the numerator equal to 0. So great question. So if I move the 1 to the other side, you get negative 1 equals 6x, or negative 1, 6. That's my x. Beautiful. If I want to find the y-intercept, I'll set x equal to 0. And let me carve out a little space here to do that. So the y-intercept will set x equal to 0. And that's going to be y equals 6 times 0 plus 1 over 4 times 0 squared plus 1. Which leaves me with 1 over 1 or 1. Yay. So I think we've got pretty much all we're going to get out of this. There is one more thing that I'll ask, and that'll be domain and range. But let's just see that our graph matches some of the things that we've picked up here. So if you're going to make a little t-table and keep track of a few things, we've got that when x is 0, y is 1. We've got that when y is 0, x is negative 1, 6. So a little bit tight there on our graph. Let's see if we can't match this stuff and this. See if that all lines up with our notions as we graph this. And here's our graph. Let me zoom in a little bit here so we can see that, yeah, our y-intercept is what we thought it was. And numerically, we get negative 0.167. If you wanted to double check that, you could do negative 1 divided by 6 and say, oh, there's the decimal value. Yeah, okay, I get it. That's really just the decimal approximation of negative 1/6. Now, the last thing that I would ask you would be for its domain and range. And let me put a couple points here on the maximum and minimums for this function. And let's see if we can't figure out the domain and range. I'll leave it here for a second. Maybe if you're watching this later, you can pause the video and see if you can't figure out the domain and range. There's a couple ways you can figure out the domain. Now, the domain starts out as everything, negative infinity to infinity. And then we throw out places where the denominator could be 0, or you get negative underneath the square root, those kind of points. But there aren't any points like that in this one. So we didn't throw out anything. Our domain is just still everything. So your domain should be negative infinity to infinity. Or, does anyone remember the fancy notation I like to use for this? Yeah, that's script R. Nice, nice. The range you're going to have to think about. And it's nice that we can have decimals available to us on the exam because it makes it a lot easier. The range is going to be from the lowest to the highest. Now be careful. Some people give me the coordinates and say, oh, negative 0.694, comma negative 1.081 to this point here. I don't want those coordinates. I just want the range, which is going to be the y values. So negative 1.081 to 2.081. The big question for you is, am I going to use brackets or parentheses around these? Well, are you including those? Are these points actually included?
Right.
And to include those, you would use a bracket. Thank you, gentlemen. So, beautiful. Think we nailed that one. Last but not least, let's do a problem that's really from your homework. And it's just getting to this idea of end behavior. Now, end behavior is really asking you what's happening to the y value as x approaches infinity and as x approaches negative infinity and positive infinity. So as x approaches positive infinity, where does the y value go? As x approaches negative infinity, where does the y value go? So, okay, let's look at the graph and see if we can't figure that out. The graph is here. So as you're moving out the x-axis, where does that y value seem like it's getting closer and closer to?
0.
0. Yeah, it's a 0. So 0 there. Now let's work on the other direction. Keep on going back to the decimals graph. As you're moving out towards negative infinity, where's the graph going? What y value is this getting close to?
0.
0 again. Thank you. So 0. And that's it. That's all they're looking for. That's the end behavior. What's happening as you go out towards positive infinity or towards negative infinity. So, all right. Looking good with those. Any follow-up or any last minute thoughts or questions on this stuff? All right. Let me get you started on the homework, and good luck with that.